Hello, my name is Reehyang. Today I want to introduce you what is metamaterial and how to make real invisible clock, which is closely related with my research topic. It is very new and emerging issue, so it will be quite interesting to you. I will introduce myself first. I'm Reehyang, a candidate for a master's degree from Material Science and Engineering, and I'm from KAIST, which is the worldwide leader of science and technology and located at Daejeon. And as the name of department shows, the material science, in this field we study almost every materials on earth, from metals to nanobiomaterials, and also we try to synthesize totally new, different and good material. And also we investigate the relationship between the structural material at atomic scales and their macroscopic properties. Material science incorporates elements of applied physics and chemistry and even with the related with the nanotechnology. And APMD, our lab, which stands for Advanced Photonics Materials and Devices Lab, the main characteristic of our lab is combination between material science and electrical engineering. It is because our professor was majored both electrical engineering and physics. So in our lab, we do computer simulation like physics or electrical engineering labs. And based on that simulation result, we do experiments. So we are far from trial and error processes. And until now, I introduced my research field and how unique it is. And now I will introduce how to make real invisible clock. The core mechanism of invisible clock is quite simple. Using invisible clock, light doesn't scatter or reflected on the surface of the clock. Just the tour around you like you don't exist there. So with metamaterial, we can make this kind of thing happen. Metamaterial may be very new to you, but don't worry, it is. It is very simple. The metamaterial is composed of many artificial lattice of megaatom, which is well-aligned periodic nanostructures. The unique feature of metamaterial comes from this part. Is if the artificial structure is smaller than wavelengths of photon, the light particle notices that cluster as one large mega atom. In this situation, optical property of that material becomes very special and totally different from normal material around us. That means light doesn't go straightly, but going zigzag or fluctuating. And using that property, we can make invisible clock, especially metamaterial with metal nanoparticle like gold or silver. Having well-defined structure can be used at visible range. Then why don't we make right now? Let's see current status of metamaterial. Actually, light consists of various wavelengths from gamma rays to long radio waves. However, current research of metamaterial usually focuses on IR or over IR range. And currently some research team demonstrated visible range metamaterial, but it operates very limited conditions and also it affects only narrow wavelengths such as only red light or only green light and so on. But real invisible clock is not like that. All we know that real invisible clock should operate at broadband wavelengths, especially at visible light range, because human being only can see that visible range, right? And our lab found that special solution using metal nanoparticle. With well-defined metal nanoparticle, we can make broadband metamaterial. Here are two requirements to make good metamaterial with metal nanoparticle: the good alignment of particle and also uniform structure of particle. As I mentioned before, we can approach to the good results with two kind of ways. The first one is computer simulation and for experiment design, and the second one is real experiments with nanoparticle based on the simulation results. And here is my real research results. I did FDTD simulation, which stands for finite finite differential time domain simulation, and I did spin coating or drop casting of nanoparticle too. In summary, metamaterial has unique optical properties, and it makes light go strangely. An invisible cloak at visible range can be achieved using metamaterial. So thank you for listening my presentation about metamaterial and invisible cloak. If you have any question about it, please email to me or visit our lab homepage I mentioned here. Thank you for listening my presentation.